Hi and welcome you all. In this video we will discuss the memory organization in 8051 microcontroller. We know that this is the architecture of 8051 microcontroller. It is an 8-bit controller IC, and it is having internal memory, on-chip oscillator, and IO ports, 4 different IO ports, and special function registers. While compare with the microprocessor, these are all the additional added features of 8051 microcontroller. This is well known to us. So in this video we will discuss how the memory inside, internal memory in 8051 is getting organized, and purely we will discuss about the internal RAM only. And also we know that the memory inside the 8051 is divided into two different parts, and which is program memory and data memory, that is read-only memory and random access memory. And we can able to connect the external program memory, that is 64 KB of external program memory we can able to connect with the 8051, and also the external RAM is also having the maximum sizes 64 KB. And the speciality in 8051, it is having internal RAM as well as ROM, and the ROM is internal ROM size is 4 KB, and internal RAM is 256 bytes. So this picture will clearly giving an idea about the memory organization in 8051. And within the chip itself there is ROM with a size of 4 KB and RAM with a size of 256 bytes. And we can able to extend the memory by 64 KB RAM and 64 KB of ROM. Okay, we will consider only RAM organization in this video lecture. On-chip RAM is actually 256 bytes, already it is clearly described here, and how these 256 bytes are getting organized within that 8051. Okay, that is the main agenda of this video. So on-chip RAM, this is 256 bytes. Okay, we know that 1 byte is nothing but 8-bit, right? So 256 byte means there are 256 locations are there, right? So it is look like an 8-bit register. Okay, it is a storage space, like okay. So likewise there are 256 locations are there. Okay, 256 locations are there. Each location can able to store 8-bit of information. Okay, right? So 8-bit or 1 byte, both are equal, right? So here you should note one thing: on-chip RAM is 256 byte. That means there are 256 locations. Each location can able to store 8-bit of information. So locations, if you are giving a numbering for each and every location, means in decimal the starting location, address of that particular location is 0 and ending address will be 255. Okay, totally 256 address locations. If you are clearly mentioning in hexadecimal, means it will have only 2 digits, right? 00 to FF. This is the hexadecimal address of the 256 locations. Okay, so this 256 locations is divided into 2 half. That means internal RAM, actual internal RAM for 128, lower 128 bytes are allocated for the internal RAM, and the higher 128 bytes are allocated for the special function registers. Okay, so 256 is now getting divided by 128 and 128. 128 bytes. 256 is divided into 128 bytes locations. Okay, then the starting and ending address. Okay, in the in decimal format, the lower byte 128 byte is having the starting address 0 to 127. Okay, similarly the special function registers are having the address like 128 to 255. Okay, so this is the starting and ending address in terms of decimal. Okay, we always prefer the entire representation in hexadecimal because we can able to reduce the number of digits. Okay, so we can able to see this is 255, right? If you are, this is to 127, right? If you are mentioning the entire address in hexadecimal format, we only in the need of 2 digits. See, the hexadecimal address is 00 to 7F. Okay, this is called internal RAM address in terms of hexadecimal, right? So 00 to 7F. Similarly, 128 to 255. Okay, both are three digits in decimal. But if you are representing the address in hexadecimal, you can only in the need of you are only in the need of 2 digits, like 80 to FF. Okay, so this is the address informations related to that on chip RAM. Okay, we'll look for the SFR first of all. Okay, yes, SFR 128 bytes, right? So there are 20 different SFRs are there. SFRs means special function registers. As its name depicts, the register which is useful for the special functions. Okay, special functions is these are all the special functions, right? The register which is useful for storing some informations. IO, I mean the registers dedicated for the connecting IO devices. Okay, the main application of the registers is connecting the IO devices. That is called IO port registers. Memory pointer registers. The special function is pointing the memory address of the particular data. Serial communication. Okay, the register which is associated for the serial communications. Okay, so enabling the serial communication. Okay, buffering the data while serial communication is working. And like this is the registers for SFRs for serial communication. And stack operation registers, timer control registers, power control registers. So this is the 20 different special function registers which is available in 8051. See, accumulator, P register, PSW, I mean program status word. This is the flag register in 8085. This is similar to flag register in 8085. And port registers P0, P1, P2, P3, and DPTR, data pointer, SBUF, serial buffer, SCON, serial control register, SP, stack pointer, TMOD, timer mode selection register, TCON, timer control register, TH0, TL0, TH1, TL1. These are all the timer counter registers. Okay, timer count register, sorry. If you want to access timer 0, timer 1, 8051 is having two timers, right? Timer 0 and timer 1. If you want to use timer 0, you need to set the count in this register only. I mean timer TH0 and TL0. All the register are 8-bit registers. Okay, PCON register, power control register, and IP and IE, interrupt priority and interrupt enable registers. See, these 20 registers are arranged in this specific memory location. I mean from 80 to FF. Okay, this is the actual location. Actually, special function registers are the storage space, right, where we can able to do some special task like timer, serial communication, interrupt, and some IO accessing. Like these are all the some general, these are all some special functions. So in order to do these special functions, these special function registers are organized. Where it is organized, where it is located, it is available, it is located in that internal RAM only. It is located in the top of the internal RAM. I mean top 128 byte location is dedicated for the special function registers. Okay, and then what about the internal RAM? I mean the where we can able to read and write our temporary data. I mean ALU need some space, right? ALU is need some RAM area to store the intermittent data or temporary data. Okay, so the 8051 is having 256 bytes of internal RAM, but only the 128 bytes are given for the scratchpad RAM application. Okay, so I mean the temporary data read and write application, the scratchpad RAM means the memory location that is allocated for the temporary data read and write operation, right? So this is 128 byte of RAM. The starting address is already given 00 to 7F. So this is organized with 3 different subsections. So this is divided into 3. First portion is register bank, that is 32 byte, and second portion is on the top of that register bank we will have bit or byte addressable RAM, that is for 16 byte. Okay, so on the top of that bit addressable RAM we are having the actual scratch pad for 80 bytes of location. Okay, so this 120 byte is divided into three different memory locations: 32 plus 16 plus 80. 32 plus 16 plus 80, that is 128. Okay, so the starting addresses like register banks 0 to 31. Okay, this is the decimal representation: 0 to 31 and 32 to 47 and 48 to 127. If you want to represent in hexadecimal, you can see this 00 to 1F, 20 to 2F, 30 to 7F. Okay, so register bank, see, this is the actual scratch pad. Okay, so ALU, I already told, right, ALU is in need of some locations, okay, to hold the temporary data while calculating anything. Okay, while performing any task, ALU is in the need of some temporary storage space, that is called scratch pad, that is called technically called as RAM, right? So the ALU will do read and write operation. Okay, so for that actual space is 80 byte, this 80 byte in its own internal RAM. Okay, so within the space itself ALU can do read and write operation. Okay, any kind of internal, I mean any type of temporary data can be stored into this memory space and it can be retrieved at any time by the ALU. Okay, and this is the very special memory locations. Okay, like bit addressable RAM. Okay, so ALU want to store single bit of information. This is the memory location for that. Okay, this is very special feature in 8051. 8085 is not having bit addressable instruction, at least. Okay, right, it is not even having bit addressable instructions. Everything will be in terms of byte only. Okay, in 8085 I think we can able to compare the we can able to check whether the carry is set or not. Okay, accordingly we can able to jump only. Okay, jump carry, jump on carry, jump on no carry, likewise we can able to do some process. But in 8051 that is a bit addressable bit related instructions in 8085. But 8051, okay, that is actually a drawback. Okay, we cannot able to store and retrieve a single bit of information in 8085. Okay, we are not having sufficient memory organization, one, and also we are not having any kind of instructions for that also. But in 8051 that additional feature is given to 8051, that is bit addressable RAM is available, which means this 16 byte. Okay, like if you count this memory location, there are 16 bytes, like, so 16 bytes of a memory location can be used as bit and byte. Okay, 16 byte means 16 into 8. Okay, 16 memory locations, 16 memory, I mean each and every memory location can able to store 8 bit of information. Okay, if you want to use 16 into 8 means 128 16 byte of memory location, so 16 into 8 means 128 bits. Okay, so within the specific area the ALU can able to store and retrieve 128 bits. Are able to feel the difference between bits and bytes, right? So each and every location, I mean 128 locations are there, 128 bit locations are there. Microcontroller can able to store and retrieve each single bit if it requires. Okay, so this is the very special feature in 80, very important feature in 8051. This is the bit addressable location, right? So we will comes to the register bank now. This is also an additional feature in 8051. Register bank is nothing but this is actually totally 32 byte locations, right? 32 is divided into 4 groups, like 8 8 8 8. Okay, 8 into 4, that is 32. Okay, so 8 bytes that makes one bank. The next 8 bytes is arranged as the second bank. I mean bank 0, bank 1, bank 2, bank 3. Okay, so within that single bank, 8 bytes, 8 locations are there. Are you able to understand? So 8 bytes are named as R0, R1, R2, R3, R4, R5, R6 and R7. And similarly, bank 1 is also having R0, R1, R2, R3, R4, R5 and R7. So bank 2, bank 3. So each and every bank is having 8 locations. The locations are named as R0, R1, R2 up to R7. So totally 4 banks are there. 4 into 8, 32. So this 32 byte of memory location is arranged in this manner. So this is the actual registers available in the 8051. 8085 is having the registers like accumulator, B, C, D, E and H, L. Right? Totally there are 7 registers available in 8085, that already we know. In 8051, the main registers are accumulator and B registers. Okay, apart from that, there is no more register like C, D, E, H, L. Likewise, there is no more register. We are having only R0 to R7. Okay, we are having 4 different R0 to R7. Are you able to understand? R0 to R7 is nothing but the single representation. Okay, if you are selecting the bank 0 and telling R0 means this R0. Okay, I mean telling means in your program itself you are telling R0 means initially by default bank 0 is selected. So if you are telling R0, R1, R2 in your program means microcontroller will consider this R0 to R7. Okay, if you want to choose this R0 to R7, okay, can you able to see from the bank 2 itself there are more one more set is available, right? So 4 sets of R0 to R7 is available. If you want to access the R0 to R7 from the register bank 2 means you have to select. The programmer have to select. Where he will select the register bank selection bits are available at the PSW. Program status word, right? This is the one special function register. This is similar to the flag register in 8085, right? So it is having it is having the 2 digits, that is for register selection bits. Okay, RS0 to RS1. I think D0, D1, D2, D3 and D4th bit of that PSW register is having the provision of selecting the bank register bank. Okay, if you are setting 00 here, bank 0 will be selected. 01 means bank 1 will be selected. 10 means bank 2 will be selected. 11 means bank 3 will be selected. Okay, while resetting the 8051 microcontroller, by default bank 0 is selected. Okay, while reset everything, PSW will get 00 in all bits, right? So if you are setting RS0, RS1 is 00 means bank 0 will be selected.